Hello everyone. In our past lecture, we discussed the logic gates. Logic gates form a very huge foundation on which electronic devices are built. And these include the microcontrollers, the processors. At the heart of the microcontroller, there is a microprocessor. And behind these microprocessors, there is a huge foundation being built by logic gates that are responsible for arithmetic and logic operations. Now, in this lecture, we are going to look at the AND gate and the OR gate. How are they used? And then they are truth table, and then we verify the results of the truth table in our circuit simulator called multisim. So let's begin with the AND gate. The AND gate has two inputs, one and one we have a zero, that is a low input, and a low input. Then the output is low. Then when you have a low input and a high input, you have a low output. When you have a high input and a low input, you have a low output. When you have all your inputs being high, then you have a high output. Basically, this AND gate, its operation is like a normal mathematical multiplier. In other words, it does like the usual, it's analogous to the multiplication circuit where you have one input or one value multiplied by the other. So that's how you can easily understand it because uh, in just getting it like the way it is, it might be difficult. But assume you are doing the normal multiplication. So let's go right away to our circuit simulator and begin the building of this logic gate. So this is multisim, and then we are going to immediately go to importing of our components. So we place here on the basic. First of all, we are going to get, we can, okay, let's import a switch. Let's import a switch. We get another one. Then we go and look for a battery or a power source. We need a DC power. Then we shall need also the ground. We need the ground. Okay, then we need our logic gate. Let's go to all groups and we look for AND gate. The AND gate that accepts two inputs. So let's take it there. Then you want to get also an indicator. Let's get it from the basic, among the basic components. Okay. Okay, we have indicators, and here we can either pick this bulb. Let's pick this bulb of 4 volts, 0.5 watts, and we put it there. So we want to have this bulb indicate our output when we close one switch and open the other one, when you open all switches, so that we test the functionality of the AND gate. So now let's do the building of this circuit. So we have one input here, we have another input here, then we have our source of those number of volts. Then we can also flip this or rotate it by 90 degrees clockwise. Then our output from the AND gate will pass through or will go to the bulb. Then we need to connect the end of this bulb to the ground or the negative side of the battery. So we have our input coming to the AND gate through the switch S1 and another one through S2. So let's connect this negative terminal of the battery to the ground. So let's decrease this value to 5 volts since majorly the transistor logic where these particular gates are constructed from, uh, the battery or the voltage they work with is always around 5. It is actually also opposite to the CMOS or the complementary metal oxide semiconductor uh, logic gates, which work with volts ranging from 3 volts to around 15 to 18 volts. So let's move ahead and first of all test this circuit using our truth table. So we have an AND gate with two inputs all being low. So if they are all being low, our output is going to be low. So let's run this circuit and see. Okay, so there is no light on this bulb, and so our output is low. Let's now close one switch so that we test this one and 0. So if we have 1 and 0, that means high and low. We have a low output. See, we still have a low output. Let's now open this and close this so that we test this condition of low input, high input to get a low output. So still we don't have a light here, meaning the output is low. Now let us close this switch. Wow, you can see when all the inputs are high, the output is high. That is the operation of the AND gate. So let's go and test now the operation of the OR gate. So I'll remove this by first running this circuit so that this bulb goes off. I open this, then I go and look for the OR gate. So let me go to OR groups, then type in OR gate. Let's take the OR gate that accepts two inputs. Cross that. We connect our inputs to the OR gate and then the output to the indicator, which is our bulb. So now, according to the truth table of the OR gate, when all the inputs are low, the output is low. When one of the inputs is high and the other input is low, then the output is always going to be high. When all the inputs are high, then the output is going to be high. This OR gate is analogous to the addition operation of any other circuit. For example, calculator, when you get any value plus the other value, you get, for example, if you have 0 plus 0, you have 0. If you have 0 plus 1, you have 1. 1 plus 0, you have 1. 1 plus 1, since it is logic, we have the output as 1. So this is analogous to the normal addition. Now, that is how you can easily remember this OR gate. So let's go and test the OR gate in multisim. So now our circuit is already set. So what we do, we run this circuit. So all our inputs are low and therefore the output is low. Let's now test if one of the inputs is high and the other one is low. Okay, so this input is high. You see, we have a high output. Then let's open this and also give this one a high. You see, we have a high output. Let's now give this logic gate high input. Let's first do that. Then let's now close all these switches and then run our circuit. So obviously you can see that when your inputs are high, the output is going to be high. Yes. So this is how you can test your logic gate